Hi everyone, my name is Lee again. I'm going to discuss about the paper which title is on the feasibility of Wi-Fi based material sensing. The following contents are following the headline of paper, and I expect the section 7, limitation of intuition, because limitation of intuition was partially described on the other sections. In the past sensing system, there is a lot of research about tracked nearby object detection, but in sensing space, do not sense the material completion of the nearby objects. But in the wireless radio sensing of objects, there is a need to be aware of the type of objects. Let's look at the picture. When these drones sensing the material of nearby objects, the function of sensing the material of object is adapted on this drone. Drone can aware of the type of object around this corner. If that object is drawn, it can swerve upward to avoid that. If person, it would give a human a wide berth. But state-of-the-art sensing solutions do not consider the localization and occluded objects. About the camera, it can localize and identify nearby objects, but it operates solely in line of sight. Laser is to bulky devices, so it is not portable and too expensive, and more power consumption needed than Wi-Fi. Unlike the above sensor, Wi-Fi based sensing systems can penetrate wall and obstacle and cheap and very small, so portable. So in this paper, also throws the question to us: can commodity Wi-Fi radio sense the location and type of moving objects? And then they give a solution that is Intuition, which is the solution of that question. Intuition is a system that explores the feasibility of identifying both the material and location of surrounding object using commodity Wi-Fi. The main idea of Intuition is that measuring the wireless signals that reflect off objects, then capture the polarization and analyze it. When the material of the object is metal, the wireless signal absorbs and emits the wave. Smooth surface reflect the waves with polarization intact, and loose surface or scatter the waves and diffuse polarization. So, Intuition determines the material of objects through the character of reflective wave from the object. The idea of Intuition is inspired from the LiDAR polarimetry that distinguishes between traces of fields and events in soil moisture using reflected signal through the recent research. So they changed the sensing device to LiDAR signal to Wi-Fi signal. There are 3 mutually identical polarized receiving antenna on the proposal of this paper, and these 3 mutually perpendicular polarized receiving antenna and 1 vertically polarized transmitter antenna, all of which are on top of enabled Wi-Fi device. This is Wi-Fi device chip. So when simplify the Intuition workflow, it just measures the Wi-Fi signal and compare the measure power of the signal through that 4 antennas, and transmitter and receiving the reflected wave on here, and then Build a MRP with parameters such as size, thickness, texture, distance, and angle of the object to infer around the object or distinguish among objects. That is the procedure is sensing of material in the intuition. So the overall workflow of material sensing is simple, but there are many implied technology and challenges are existed. The first challenge is that detecting and discarding the signals that are reflected and scattered from multiple objects sequentially. In Intuition, these are handled by reverse engineering and recognizing the Wi-Fi signals polarization compounds. Second challenge is separating the signals that reflect exclusively of each individual object in the environment in three-dimensional space. That is handled in Intuition by measuring the time of flight they experience as they reflect off each obstacle over a brief slice of time. In this paper, for easy explanation, two-dimensional environment is considered instead of three-dimensional environments. The third challenge is that hardware non-idealities of wireless radio that induce random errors in the measured time of flight. In Intuition, there are two pathways, wired and wireless path. Wired path gives estimating the timing offset to correct for each effect on the wireless path through the synchronization. Other challenges are carrier frequency offset, sampling offsets, phase shift between the transmitting and receiving RF chain. Other challenges are handled later in this paper. About the Intuition developing environment, Intel Galileo board equipped with 5300 Wi-Fi card chip and take feasibility in large indoor and outdoor spaces and distinguish the material type. In the Intuition distinguishes the five material, which is the five material: copper, aluminium, humans, polluted, and birch in a variety of line of sight, non-line of sight, stationary, and mobile settings. UAV, which means the drone, which is mounted above Wi-Fi platform, is used for testing the classifying between humans and drones for indoor and outdoor. The contribution of Intuition is that detecting the material and location of occurring obstacle, opening up application for mobility platform. Section 2 is related work. There is many sensor systems using Wi-Fi signals. For example, activity recognition, occupancy sensing, imaging and location tracking, and so on. The cross-related work on this paper is that material detection system, which can detection system that can detect material by sensing how signals are attenuated by objects placed between transmitter and receiver. But past sensing system based on Wi-Fi is not portable, so not matched to mobile computing. Past sensing system was needed the infrastructure, but the purpose of this paper does not need infrastructure. And LiDAR parameter is a synthetic aperture LiDAR parameter for topography imaging. First began 나포터벌써 also leverage the LiDAR parameter and move that technology to commodity Wi-Fi card chip. So Intuition overcomes challenges such as the near-field effect and imperfections of such radio that early solved problem in LiDAR. Camera's LiDAR and depth imaging often used to detect graded objects, for instance by autonomous platform, but this sense of circling direct field of view, they fail to detect objects daily or graded. About our relative work, Intuition has a disadvantage that needing no infrastructure and seeing the environment via refraction rather than penetration. Section 3 is parameter for sensing. This picture presents the three instances of scaling responses for a polarized incident wave. A is a smooth no-metal surface. The reflected wave maintains the linear polarization with polarized right, and B is a smooth metal surface element. smooth metal surface, and the right is reflected without linear polarization. And since the loose surface is scalar of a wave and may induce polarization based on the material, character of material. Okay. So Intuition, through this property of reflected wave, classify the texture and material of object. An incident. Okay. To better understand, let's consider a surface defined by parallel and perpendicular vectors P and S. According to the 70s reference on this paper, an instance as polarized signal can be denoted as first equation in now on the PPT screen here, and to briefly explain this equation, EST means the function of electromagnetic waves. Maybe this equation, EST equation, means that the power of wave or property of wave, and this T is just means time period, and big A represents the amplitude of polarized wave. This omega is frequency of specific material, and vector to the power of S means unit vector. So these equations represent the power or character of the wave. But Intuition, these equations separated to RSSE power 2S RSPEP. The features that surface, amplitude, pace, and orientation can all be affected, so it resulting in a reflected signal equation in the screen. This RSS and RSP are complex numbers describing how the S-oriented incident wave has changed in pace and power on each of the S and P components. Note that when pace shift is emerged, the linear polarization will be changed to circular or elliptical that caused by the sum of the frequency of two waves. But when the change by same amount or by a sector of pi, the linear polarization is preserved. And intuition can gathering the separate of x-axis and y-axis on polarization wave through the linear polarization. Through the linearly polarized receiving is three antenna. Is receiving three antenna. So you can gathering the RSS and RSP. So intuition equation ERT means the property of wave defined by intuition's sensing systems. Receiving this calculated signal, which is from referring the 17th reference on the paper, intuition can take the ratio of signal to remove power and pace shifts due to the propagation. The third section is intuition in a nutshell. This picture gives a simple workflow of intuition. In the first scale area, intuition is the time of flight of reflected signal from an object to develop a filter that outputs the wireless channel components. Then, in second scale area, it processes the signal components on a horizontal and vertically polarized receiving antenna and measures the ratio to determine to which the reflection impacted the polarization of the transmitted, and makes the vector, which is used to MLP as a parameter that determines the material and type of the object of interest. This is the result of MLP classifier, which is the part of the processing the signal of intuition. Intuition is stretching the features from the polarization, which is reflected signal from the surrounded objects. It features the subset of wireless channels, each spanning a different range of frequencies to obtain the wireless channel components reflected from the object of interest. Object of interest is the target object. To know the localization and type of material, just a term of this paper. Then compare this channel at the horizontal and vertical antenna to study their polarization across subsets of frequency bands, and then feed the ratio between channels and channels at the horizontal and vertical antenna into the MLP models to process the feature vector and infer the object material and type. Second is sensing mobile object over time. There is a big challenge object to track all objects that are themselves moving with a time. When trajectory intersects of multiple objects is emerged, intuition just track each object using the type of material, which is determined by material of type of object. This solution is described as section 5.1 of this paper. And intuition improved the localization and material sensing to each other's performance that is shown in section 5.2 in this paper. About the locating surrounding object, Intuition uses the 4 antenna to get the location of objects. The wireless channel on Wi-Fi are a combination of signals propagating along different paths as they reflect off barriers surrounding objects. So Intuition processes these wireless channels across Wi-Fi frequency bands and measures the time of flight experienced by the signal along its path. And then, when speed of light is multiplied on that result of processing, it provides the distance traversed by the signal from transmitter to the reflector and then back to the receiver. With the distances which is calculated from multiple perspectives as the drone flies in the 3D dimensional spaces, Intuition triangulates the 3D dimensional positioning of the surrounding object. This method that tracking the object without infrastructure has several new challenges. First is this untangling signal paths. Intuition must separate the signal paths from various objects surrounding the mobile device. So it must exploiting the mobility of device itself. Section 6.1 in this paper presents the processing the received wireless channels across a special location and frequency of operation of Wi-Fi radio to get the time of flight and angle of surrounding objects. Locating accredited objects. Second challenge, to perform the intuition without softening of infrastructure, Intuition needs an algorithm that can analyze weak reflection from distant objects and those that were created by other objects. Intuition achieves this by sensing changes in the wireless channel from weak reflection to detect the presence of the moving object that produced them. So, Intuition leverages a novel background subtraction algorithm that eliminates the effect of the drum movement in the wireless channel to detect the movement of surrounding objects. The hardware setup is represented on this picture. Symmetrically perpendicularly polarized receiver antenna and one vertically polarized antenna. If there are no reflector on the picture, no material. When no material here, is the reflector is not existing. The transmitter sends a single signal polarization pattern through the wired path. When there are reflectors existed, all of the receiver antenna receive the signals through the path 1 and path 2. Path 2 is a pattern of polarization depends on the material of the reflector. Through that hardware setting, Intuition obtains the polarization to the reflected signal from a given object across frequencies, and then it extracts features via multi-layer perceptron that closely correlate with material composition of the object. In the MRP, the key challenge is that decouple various other factors that influence the wireless channel, such as object size, texture, and orientation. Next section shows handling of that key challenge via MRP implementation procedure. Prior to extracting the feature of object, Intuition uses the object location algorithm to filter the virus channel from an object of interest. It measures viruses channel at all received antenna across all FDM subcarrier, which is digital multi-carrier modulation schema that extends the concept of single subcarrier modulation by using multiple subcarriers within the same single channel. Further, Intuwition refits the localization algorithm over many different subsets of Wi-Fi operating frequencies to obtain the wireless channel components reflected off the object. Then, Intuwition creates the vector of wireless channel per antenna from the object versus frequency both across different subsets of frequency band and subcarriers. And then Intuwition computes the ratio of the channel received between pairs of antenna to eliminate the effect of distance of the objects on signal power and focus instead on polarization, which is highly related on material of object. And the result of 3 channel ratio sampled across frequencies represents as a vector of over 1,000 elements. And then all of the vector from 3 receiving antenna prey on input to MLP machine learning model, but there is a probability of emerging overfitting. Also, the MLP model selects a subset of features from the wireless channel ratio across frequencies. Then, it removes the sample which have missing value among those 200, so it reduces the number of features to avoid overfitting. And MLP model in the Intuwition takes MLP models to classify the material of objects among other machine learning models. And 2 MLP models adopt on Intuwition. Each MLP's output or material class and object type. The reason of choosing MLP model is that it has a higher accuracy than other models. The results of accuracy among machine learning model will discuss on the experiment section later. The Intuwition's MLP models are trained with 200 features, and to avoid the overfitting of the training model, also correct the training data in different radio environments, indoor and outdoor, across multiple days. These features were selected as the most impactful out of all the paper ratio between pairs of antenna captured at frequency across large bandwidths. About the training data, they randomly surface the data every time after 1 batch out of 500 times. About the ambiguous trajectories, Intuwition explored the localization to isolate and found the material that objects in the environment are made of. But sensing the material of the object can also improve the performance of localization of multiple objects. Let's see the picture. Human bikes are miss the path of crossing. It has difficulties to know the trajectory on the crossed object like here. So, but there is a limitation. But Intuwition can distinguish the 2 objects when they are crossed, which has intersect each other via knowing each material of objects. It means that when two objects are intersected in this spot, the intuition can't detect the material bike and material person, so you can classify the two objects when they are intersected. But there is a limitation of intuition. When intersect objects or have a same material, it means that this line is not bike, just person, and you cannot distinguish the two objects. So authors infer that it can be handled with another parameter, which is size, shape, and designated aforementioned problem as a future. And the second challenge is that intuition resolves is to eliminate spurious reflection of multiple objects before reaching the receiver. The spurious multi-object reflections means that polarization from the not interested object. The research polarization observed is a combination of the properties of all materials through which the signal reflects. The phase shift of RSS and RSP may be the complex material number of the signal received that captures signal. Polarization is the sum of the RSS and RSP values of each material. Spurious multi-object reflections that to handle the spurious multi-object reflections, intuition searches objects based on their observed value of the time of flight, which is measured distance relative to the surrounding objects. Then, it progressively labels each object as estimates, only marking objects as spurious if each phase shift is the sum of subjects of estimate phase shift. And intuition must deal with the characteristic of object, so it must consider the object size, orientation, texture, and location, which are the information that impact on the wireless channel. The effect of location is that the influence of channels emerges by distance from multi-objects. In the example of effect of location is between a nearby wooden seat and a distant metal sheet. Intuition uses the power ratio of the channel from a vertically polarized transmitter to ensure that the distance traversed to the reflector is effectively factored out of radio reading. Varying refractor size and angular orientation would pose a similar issue for power-based material identification. These properties are captured in data range by a property alpha radar cross-section. RCS, which means a radar cross-section, is a criteria for measuring reflected waves, and it is the value associated with what size an object's reflection, independent of what its dimensions actually appears to a radar sensing system. So, Intuition uses the multi-antenna approach to measuring rotation in polarization would be affected by the same effective area across all these antennas. So it removes the effect of size and angle orientation from isolating material. About the effect of surface texture of material, surface texture and material composition can be decurved by looking at the window of refracted barrier. Instead of a single point polished surface, show a distinct peak at the time of flight of the reflected object. In Rose-Boring reflectors, signals transmit through the initial surface but have multiple opportunity to reflect through the width of the object, resulting in a shorter, wider peak. Next section is object localization. Intuition is to process the received wireless channel to separate the wireless signal component reflected of the object, or before sensing the material of an object of interest. Using pattern of the signals from object collected from the different perspectives, it triangulates its position. In the case of a multiple object, it removes peaks using successive interference calculation and spares the multi-object reflection based on their RS and RSB values mentioned before. And then Intuition takes a filter to extract the wireless signal components that emerges from that particular location. About the separating signal passes in mobile settings, Intuition's first task is separating signal components arriving along multiple passes as they reflect off each object in the environment. About separating signal passes, Intuition has a big challenge in combining frequency bands in mobile context, such as UAV, is that the device moves in the 3D dimensional space so that each location changes between channel measurement. So, channels across packet change both due to change in Wi-Fi frequency as well as the change in device location between measurements. To separating single pass in Intuition, in modeling both the frequency of operation and the movements of the device based on state of the wireless channel with considering both angle of arrival and the time of flight of reflecting surface simultaneously. Analyzing the state of the wireless channel is addressed in two-dimensional space to better understand. In the picture, the device moves on 2-3 trajectory that is distance Li. Li represents the distance relative to each initial position, and where's psi relative to its initial orientation and on frequency if when receiving the packet from other angle of wave. In this circumstance, the distance between the reflector and the device is much greater than displacement of the beaker across packets. Reflector does not, of the beaker across packet only for us to approximate that the angle of the reflector does not change. To recover of the time of flight and location of the object, Intuition builds upon the Barrett algorithm, which is estimating the power spectra and provides a way to reduce the variance of the parallelogram in exchange for reduction of resolution compared to standard parallelogram in two dimensions. The education represents the powerful wireless channel distributed along a distance, or maybe it is gamma and zeta. The zeta means the angle of arrival, and gamma means the distance from the mobile object. This equation is referenced by 26th reference on this paper. In that original equation, I think it needs to express the movements of an object, so it needs to replace the integral. But I don't know why the summation is used. To go over, using material sensing method that proposed in section 5, it analyzing the H, which means the extracted equation at the horizontally and vertically polarized antenna across the frequency. And then Intuition takes the optimization to eliminate sparse peaks, leveraging the proximal gradient descent algorithm, which is generated to two-dimensional to accurately localized object without being missed by surprise artifacts. I think this two equation is the optimization function. I think the expression 1, 2 in this paper are difficult to explain because there are not enough explanation in this paper. However, I think one natural expressions for optimization and the expression to which the optimization is operated is third equation. For the calculated the third equation, it seems that the signal within the optimized signal power range is a signal for a specific object. When we get this signal, power signal, and then optimizations using these two equations, and then finally we can get the optimized signal power range. So when the reflected signal is not in this optimized signal detection range, that signal is not considered on the Intuition system and discards that signal. For signals, we need to distinguish between the obstacle and the signal behind it. About the detecting a collected object, also the signals may overlap and the correct signal may not be detected. So Intuition uses the background subtraction algorithm to detect only moving objects. Let H gamma zeta be the first time, and H prime r zeta is the next time. So HR and so HR zeta and H dot R zeta are assumed to be the radio channels along a given direction R zeta, measured in two instances where the device is displaced by a distance vector d and redirected by vector zeta. If first that any object at R zeta at the first time instance is now considered as R minus vector d cosine zeta and zeta minus vector zeta, and Yeah, all of these object which is refractor distances r and vector d. Always vector distance vector d is lower than the first initial distance from reflector. Using the definition above, it is possible to detect the signal generated from behind the obstacle. So, intuition can distinguish the material of moving objects at location, even if their signals are weakened due to accretion. And know that when the refractor is static, and results of the equation, no. There's no moving on static refractor. Static object means the static refractor in this paper. There will be no change of theta, which means the angle of wave, and no change on distance. So the next signal will be got a zero value, and when moving object, there is not the results of the next signal got h r theta minus h dot r minus vector d cosine, and cosine minus vector theta is not 0. Okay. So next is implementation of intuition. After the intuition's structure and design parts are over, let's take a look at the experimental results. Let's take a brief look at the experimental environment before looking at the experimental results. There are 4 antennas and 1 transmitter and 3 receiver in the Wi-Fi structure. To measure the parameter in 3-dimensional space, the 3 receiving are oriented perpendicular to each other. And the software and runtime. All of the algorithm is implemented in MATLAB or C++, and MLP is implemented in Python. And the train location at the rate of 8 Hz and sense matrix at the rate of 2 Hz. And about the experiments evaluation, evaluate the system in 225 SQ.M outdoor garage space, 500 SQ.M outdoor plaza, and 4 different indoor spaces ranging from 43 to 400 SQ.M. SQ.M means the square miles. Copper, aluminum, birch, and maples are used to test the material test, and additionally the objects are included, such as a chair or table, variety of clothes. Data was collected at different orientation and distance over indoor and outdoors. Perform 30 tries for each material at each configurations. The UAV was measured to hover at zero speed and moves at speed up to 2 meters per second. This result shows that 3 antenna means perpendicular oriented has a higher accuracy than 3 antenna means vertical. And MLP has a higher accuracy than another machine learning models. This is This green is vertical when we set the antenna to vertical, and this means the perpendicular antenna. So MLP is the best models of intuition to classify the material of sensing. And about the object localization, this research shows the object localization of intuition in this experiment also fix fiduciary markers to object and implements a camera-based fiduciary tracking system using ArcTurkey, which refers a sub-millimeter based line localization. And about the research method and would are best to localization. Maybe there is more material sample data about metal and wooden than humans. Yeah. And in graph B, when distance be longer, accuracy is fast because the strength of line of sight signal getting lower. And next is about the material sensing and overall observations about the material sensing. Line of sight means that there is no obstacle in the path of wave, and non-line of sight represents that there are obstacles in the path of a wave. Line of sight has 95% and non-line of sight has 92% accuracy in average. When comparing system performance with multiple tracked objects, we see a negligible performance decreases for the 2 object case, of 5% decreases in classification accuracy in the 3 object case, and a 6% decreases in classification accuracy in the 4 object case. The box represents the confused objection of the same class metal, copper, and aluminum. For example, in the circle, in the box, reference 8.5, 9.1 labeling because of similar material, copper, aluminum, copper. But in UAV path planning, since the extract type of metal is not critical to the functionality of the system, so also stands care about this research. Then material sensing and thickness. About the thickness, here, this middle of graphs, we can see the thickness of wood. When thickness is getting more thickness, the accuracy is getting higher. Maybe can interpret it that for non-metallic objects, the material that compose the largest part of the reflector may impart the most significant share of signature. About the material sensing of surface area. This graph represents the result of a surface area. When surface area increases from 4 to 60, classification accuracy increases from 80% to 93% in no line of sight, 92% to 98% in line of sight is increased. Yeah, and measuring sensing of range in the result of round trip distance from the intuition to the sensed object. When distance getting longer, we can see that accuracy is slowly lower on 5 meters in the graph. Increasing of accuracy reason is that due to the resolving the reflection given the strong line of sight signal. About the major sensing of surface texture, also correct measurement from 5 surface textures of period of fixed size and thickness, unfinished rows with stirrer, painted with semi-gloss, sanded to press grade 80 grade, and sanded to 200 grade. Research shows that surface texture of wood does not play a statistically significant role in classification accuracy. In this test, the results of the object recognition of real-life obstacle in Intuwition, they also trained a new model to classify wood from metal using a corrected test and train data to create the best model possible. They test the intuition of a new unseen object on the graph B. Classification of metals appears to be slightly higher. And last, results of experiments on Intuwition, object recognitions from a mobile UAV that is drone. In these experiments, authors test the system's utility in avoiding two types of obstacles, human and other UAVs. And main focus of experiments is that capturing how the speed and vibration of drone affect the function of Intuwition. A delivery drone navigating indoor and outdoor space. Speed of drone is 0 per sec, 0.5 per sec, and 1.0 per sec and 1.5 per meter per second, and the reasons of slow speed or safety of user and limitation of UAV platform. The research show that when higher the speed, the accuracy and location has a bad result. Accuracy and the increasing of propeller's vibration impact on the location error, which in turn better sensing accuracy. Last is conclusion and future work. Intuwition evaluates 5 types of material and tracked objects only within the device without the need for infrastructure. And in the future, they will end the paper with a lot of challenges regarding object recognition systems, such as object platforms for robotic platform, which can be applied to applications that require technology such as Intuwition. Thank you.